You are live.
Okay. Hi, everybody. Welcome to the Jenkins Online Meetup. Today we are having a session about plugin development web UI. So we are going to have presentations by Daniel Beck and Tom Family. And my name is Oleg Nashev. I will be moderator of this meetup. As you probably know, Jenkins Online Meetup is a platform which allows us to meet and discuss various topics related to Jenkins, like case studies, Jenkins administration, and core plugin development. You can subscribe to webinars using the link posted on the slide. And of course, if you want to conduct a talk or propose a topic, you can contact us via Meetup page or drop us an email to events@jenkins-ci.tools. If you also interested in local meetups, Jenkins has a Jenkins area meetup program. We have about 37 meetups in different cities. You can see them on the map. You can find a wiki page which describes the process of creating meetups. And if you want to organize something in your city or join the existing meetup, you can find these meetups at meetup.com as well. Today's session is the second part of plugin development meetup series. The first session has been conducted on June. It was about classic plugin development flows and also pipeline plugin development. You can find a recording of this session on the link. This link is not very human readable, so you can go to the meetup page. And on this meetup page, you can find the link in past meetups. So today we are going to talk about Jenkins Web UI, and we also plan another session related to Jenkins test frameworks. And of course, we are going to continue these meetups and to have more talks about Jenkins plugin development. The ecosystem evolves quickly, so there are many topics to talk about. Today, Daniel will start from a classic Jenkins UI framework. Probably you know what is StaplerJelly forms and also Groovy defined UIs. So it's an old framework which we commonly use for plugin development. This framework is very stable. It's pretty effective. And even if it's not so modern, we use it effectively. In addition, currently we are working on many improvements related to web UI development. Maybe you've heard about projects like Blue Ocean, like setup wizards in Jenkins 2, etc. And all these projects are built on the top of new UI based on JavaScript. And Tom is going to talk about this technology after Daniel's talk. Both talks will take about 1 hour, including questions. And we are going to record these talks, and the link will be posted to the meetup page within 1 day after the webinar. If you're interested to see other videos from previous meetups and other events, you can find these video recordings at the Jenkins YouTube channel. During the meetup, we are going to answer questions submitted by users, and there are 2 options to submit this question. Firstly, you can use Q&A tab available in your YouTube layout. You can ask your own questions, vote for other questions, and after the presentations, I'll try to ask these questions, and speakers will respond to them. If we have too many questions, we will answer them using a follow-up blog post on Jenkins.io. In addition, you can ask questions using the Jenkins RC channel, and we will also try to collect all questions from there. That's all from me, and I would like to pass the presentation to Daniel Beck, who will talk about classic Jenkins web UIs. Daniel, are you ready?
I am. Thank you, Oleg. Hi, everyone. My name is Daniel Beck, and I'm going to talk about UI development in Jenkins today. First, a few words about me. I'm a contributor to Jenkins for more than 3 years now. I'm a core committer, the Jenkins project security officer, and occasionally, as you can see, I work on Jenkins project infrastructure. And as a day job, I work at CloudBees. So what is my talk going to be about? First, I will discuss stapler request handling as the basic concept of how you get from an HTTP request to whatever answers those requests, as well as ways to investigate what goes on internally in Jenkins, because that's due to the power of Stapler, that's not as clear as it could probably be. In the second part of my talk, I will explain how to create views in Jelly and Groovy. I will discuss control flow, internationalization, and commonly used variables and methods that make it really possible to work with these technologies inside Jenkins. And in the last part, I will talk about view composition, which is comprised of reusable UI components or tag libraries, and as well as the inheritance and action models of composing views. Most of this talk is concerned with Stapler. Stapler is a UI framework used in Jenkins and really nowhere else. Initially created by Kosuke, same as Jenkins. It is it is the glue or the staples that keep everything together. And the name comes from the fact that URLs map basically directly to model objects. What do I mean by that? Let's talk about request processing. At the top, you can see a request to a Jenkins instance, fairly common one. CI Jenkins-CIO is the host name, and then /job/demo, demo being the job name here, /1 a build number /changes. This would display the changelog for the first build of the demo project in Jenkins. And to the bottom, you can see kind of in pseudocode what Java code this translates to. First, we start with the Jenkins singleton instance, and then we can see we call the getter called getJob with the demo argument, and you can see right there something's going on. 2 segments of the URL path combine to one getter call. The next part, getDynamic, where is that coming from? I will show you in the next couple of slides, but you can see the one in the URL translates to that call, and in the second line we finally render the view, in this case a jelly-based view. So what are the common ways to process a path fragment? And by path fragment, I mean the part of the URL after the host name before the query string. So everything between the slashes, basically. First, there are methods to traverse the model graph, such as calling a getter. For example, in Jenkins, if you access the log manager or system log, as it's called on the UI, /log, this will be translated by Stapler into a call to the getter getLog of the Jenkins object. You can have getters with arguments, as seen on the previous slide. /job/foo gets translated to a call to the getter getJob with foo as the string argument. This variant supports strings, integers, and longs. And then there's the dynamic getter. What does that mean? If there's no other preferred alternative to interpret a path component, then Stapler looks for a getter called getDynamic and passes the path fragment as a parameter. There are ways to render views. For example, the index view /job/foo/ will look for a view called index.jelly or index.groovy and render that. The view, of course, must belong to the job type. I will show how that happens later. And there's named views. So if we navigate to a job /job/foo, and there's a name afterwards, in this case changes, Stapler will look for a view called changes.jelly or changes.groovy and render that. And then there are the action methods. You've executed those whenever you access a job's artifacts. In this case, the /artifact translates to doArtifact, a method of the job type. Or in the case of program access to the config XML, either get or post, it will call a method called doconfig.xml, and the association between the URL and the method is done through an annotation on the method, as you can see here. There's the index action method. If the request ends similarly to the index view, you can programmatically define a method in your Java code that handles this request and writes the HTTP response directly, as is the case with the search results in Jenkins. There's the dynamic action. It handles basically any URL. The idea here is you want complete control over what happens in the current object. One of the examples is while Jenkins is loading or restarting, it only shows a screen Jenkins is loading or Jenkins is restarting and nothing else, no matter what specific URL you're navigating to. And that is done using doDynamic. The order in which I presented these here is not the order in which Stapler tries to access them. Rather, it's the order by the kind of method accessed. I will go back to the priority order in a few slides. Besides the common ways to process a request, there are also less common ways. These are mostly used in more tricky situations, but since we're doing an in-depth look at Stapler here, I'm going to talk about these as well. These are StaplerProxy, StaplerOverridable, and StaplerFallback. So what do they do? StaplerProxy is an interface that allows you to delegate further request processing to another object rather than continuing with the current one. And this method has priority over everything else. So if Stapler, in the course of figuring out how to process a request, arrives at an object that implements this interface, then it calls the getTarget method to get an object back. And it will continue to process this request using that object. You can return this, which in Jenkins core is used to implement permission checks. You can do a permission check. For example, you need to be administrator to access a specific object through the UI. And you can, in getTarget, implement that permission check that throws an exception if you don't have the required permissions, and otherwise return this, and then Stapler will continue with this object and the other ways to determine how to process the request. There's StaplerOverridable, which is similar to StaplerProxy. It allows overriding parts of an object's request handling. So It has priority over everything else but StaplerProxy. And if Stapler, during request processing, trying to figure out how to handle the request, arrives at an StaplerOverridable, it calls the method getOverrides to get a list of objects. And it will try to continue processing the current request with these objects in the order they were returned. And if that fails, it will just continue with the current object. The idea here is that you want an extension or plugin to extend parts of a certain object's UI. But if you have no such plugin installed, for example, you want to get kind of the default behavior. And then there's StaplerFallback. It also is an interface that allows you to delegate further request processing to another object. However, different from these other two, it is invoked last. So if all else fails, try the fallback. And that is implemented as a method called getStaplerFallback, which will return an object, and Stapler will try to continue processing the request using that object. This is one you're using every day because Jenkins, the singleton that is the root of the URL, space implements StaplerFallback, delegating to the primary view. Basically, that the primary view configured in Jenkins is shown when you access the Jenkins homepage is closely related to this. So for example, new.jelly is defined on the view only, but /newJob, the URL, works just like /view, /viewName/newJob. And the reason for that is there's no new job in Jenkins, so that fails, and it will fall back to the primary view and render the primary view's new job jelly view. However, if something is defined for the Jenkins singleton, for example, the configure URL that shows you the system configuration, then that takes precedence over the view's configuration. You may be wondering, well, that's great, but how do I figure out how it works in Jenkins? Stapler allows you to trace requests, so you know what's going on internally and how Stapler interprets a request. You can either set the system property StaplerTrace to true to trace every request, or to only trace specific requests, set the system property StaplerTrace per request to true. And if you do that, you need to set an HTTP header in each of the requests you want to trace. For the following, in which I show how that looks like in your browser, please note that Hudson and Jenkins are basically the same type internally. So in this example, we're looking at the URL /configure. At the top right, I've listed the priority order of the different methods that Stapler will try in this order to figure out how to handle the request. And at the bottom, across the screen, I have the headers I get back when I access this URL in Jenkins with Stapler tracing enabled. In the first line, StaplerTrace 001, you can see we're accessing the Hudson or Jenkins singleton, and we need to figure out what to do with /configure. In the second line, the Hudson object implements StaplerProxy, so we get call getTarget to figure out what object will continue processing this request. It turns out it is the Hudson object itself. It returns this, as I've previously mentioned, is possible. And in the third trace line, you can see the view that Stapler found. It is Jenkins model Jenkins configure.jelly that belongs to the Hudson or Jenkins object. Another example, the /new job URL, which I mentioned earlier. Let's look first at the first 5 lines of the Stapler trace. We arrive at the Hudson or Jenkins singleton and need to continue processing the new job suffix. The second line, again, we call this to figure out whether there's a relevant StaplerProxy object here. And again, we get this back. And in the third line, we try get dynamic. As you may recall, get dynamic is called with the string argument of the path fragment we are currently processing. However, that returns null in trace line 4, and we need to backtrack. And finally, in line 5, we arrive at the StaplerFallback, and Jenkins tells us to continue processing with another object. And that other object is the so-called all view. This is the view type that's created by default in Jenkins. And in trace line 7, you can now see that Stapler has found a jelly view called new job jelly for the all view type. And the view is defined on the supertype view that all view inherits from. So that's it for the request processing in Stapler. Let's talk about views. And just to clear up any possible confusion, this is not about views in Jenkins, like the all view, which I've just talked about. So these views are not about organizing your jobs or your project in Jenkins, but these are about defining the Jenkins UI. Views are typically defined in Jelly or Groovy. Groovy, a scripting language on top of the Java runtime environment, and Jelly is an XML-based templating language and an Apache project. Most views output HTML, but that's not required. Why am I talking about Jelly and Groovy? Historically, views in Jenkins have been defined in Jelly. However, Groovy is the more modern alternative, easier to write, easier to debug. However, there's a good chance you're still going to be using Jelly for some more complicated things, just because it's much easier to find usage examples for. There are relatively few views defined in Groovy in Jenkins and in plugins. Let's talk about how to associate a view with a Java class. You can see highlighted in yellow is a Java class called Hello World Action. And it has a corresponding directory in the resources folder for this project. And inside that folder, highlighted in light orange, is a file called index.jelly. And this is a resource file for this class. Highlighted in light blue is a Jelly view that is related to no specific class, but to the plugin itself. So now you know where to place these resource files that are related to a certain class. Here's a very simple Hello World or Hello Jelly example. let's go through it line by line. On the first line, we tell Jelly to escape by default. This is cross-site scripting protection. And if we leave this out, it will render HTML unescaped. So, and we don't want that. So that's why this is always the first line. Strongly recommended. On the second line, Jelly is the document root tag for Jelly documents, and we're referencing a few XML namespaces, one with the prefix J for Jelly core itself, and one with the prefix ST for stapler functionality. On line 3, we define the content type of this Jelly document, which is HTML. If we leave that out, the browser will just show the raw XML output because it doesn't know what to do with it. And lines 4 to 8 are a very simple HTML document that just says hello Jelly in a headline. The equivalent document in Groovy, or view in Groovy, looks like this. Here we're referencing the stapler namespace again, so we're able to set the content type of the response using this method call. And lines 5 to 9, you can see how we're building up the document structure using a kind of Groovy DSL. Of course, the question is, how are we implementing control flow in Jelly? I don't want to just show hello world in Jelly. I mean, Groovy should be straightforward, but how does it work in Jelly? So in Jelly, in the Jelly core namespace, a number of tags are defined that allow you to implement things like loops and conditions, highlighted in yellow here. So for example, the outermost element is a for each loop. And inside that, we have the equivalent to a switch case statement in Java. It's choose, when, and otherwise. This is what you need to do if you have something like if else. While there is an if tag, it does not support an else block. So that's why we have a switch case with one case and a default block here, so to speak. Highlighted in blue are Jaxel expressions that access various variables. In this case, downstream, root URL, and item are variables. And the rest of that is a Jaxel expression. It reads a lot like Groovy, but isn't Groovy. So the semantics are slightly different, but it does exactly what you expect it to do. So for example, that link item.key.url just calls the getKey method and then the getURL method, expecting that a string is returned or a type that can be converted to a string. The same with display name, key value, and in that last blue highlighted element, you can see how we're calling a method. For simple text output, you just write it into the document, as you can see highlighted in red. Control flow in Groovy. There's not a whole lot to say about that. It's Groovy. We don't need special support to add loops and conditions because Groovy has them. You can see here how we're iterating over the elements of a list with the each method. These default Groovy methods and closures are all available, which makes it quite convenient to implement loops or conditions in Groovy-based views. Let's talk about internationalization. As you can see here on the left, we're doing the Jelly approach, and on the right, the Groovy approach. Let's talk about Jelly first. At the top, we have an excerpt of an Jelly view, and highlighted in yellow, you see the $sign, the curly braces, and the percent sign. And this basically means everything between the percent sign and the close curly brace is to be treated as a localizable string. Localization for views is done through Java properties files, as you can see on the bottom left. In this case, the file is named the same as the corresponding view, index, underscore, and then the 2-character language code, in this case Spanish. And it is a Java properties file, hence the file extension. And you can see it's pretty straightforward key value format. We need to escape the space in the key, but otherwise that works. And since it's Spanish and the upside down exclamation mark is not part of Latin 1, we need to insert this Unicode escape sequence here. Let's look at top right at the Groovy approach. In this case, we just insert another method call to the method called underscore. And that will basically do the same thing as the percent on the left. It will look for a suitable localization of this localizable string and insert it at this point. As you can imagine, this will result in problems if you ever change the default string. So there's also the possibility to use a fairly generic default string, in this case just hello, and create a properties file for no specific language, index.properties in this case, and have the default localization be defined there. Also makes it easier if you want to parameterize your localizable strings. In this case, we want to use parameters we insert into the localizable string. Rather than concatenating a bunch of tiny localized strings, we define placeholders and have the localized resource order them in whatever order makes sense for that particular language. In this case, we only insert the placeholder for the language name, but that could easily be numbers and other identifiers or things like dates. Let's look at the most useful predefined variables and functions. First of all, if you're in the view, you often want to interact with the object that the view belongs to. If you remember the previous example where there was an index.jelly view for a class called HelloWorldAction, maybe you want to access getters or other methods of that of an object of that type. And you can do this by using the it variable in Jelly or Jexel and the my method in Groovy. You will often see this with the parentheses left out, because as you may know, in Groovy you can often leave those out and it will still work. So you will often just see my without the parentheses. App, if you see that, is the Jenkins singleton object, which is typically used to access some kind of globally unique resource or object. Root URL is the root URL to Jenkins, which is inferred, if necessary, from the current request. And you use that, for example, if you want to create absolute links or things like that. If you want regular output in Groovy, use text method. The reason for that is everything else is basically interpreted as an HTML tag, as you may have seen earlier. You can output raw, unescaped HTML in Groovy by using the raw method. And whatever you pass as argument will be printed as is to the output. And in Jelly, the equivalent can be achieved by using the out tag. This is basically what you need to do if you have the Jelly escape by default option enabled and you still want to print something and prevent it from being escaped. So you use the out tag here. Now let's look at UI composition. What do I mean by that? You don't just want hello world views and you don't want to repeat the same thing over and over. You want to build the UIs more flexibly, and there's a few approaches you can take to achieve that. One is reusable components. They are grouped in something called taglibs, and you've already seen those. We'll show you another example on the next slide. And then there's the ability to include partial views in other views or view fragments in other views, both via inheritance and via actions, which is basically the most common approach to include new UI in something else in Jenkins. So let's look at reusable UI components. On the left, you see a complete Jelly view. And since Jenkins defines a number of reusable UI components, we can make use of them. In this case, I'm including the XML namespace with the prefix lib layout, which is where the main components of the Jenkins layout are defined. In this case, in line 3, the layout tag, which basically renders all the stuff around the main viewing area. It's the header with the Jenkins head and the Jenkins logo. It's the breadcrumb bar, the search box. It's the footer. All of that is provided by the layout tag. And I want to render something inside the main panel of the page. So I'm using the main panel tag inside the layout tag. And this is what this looks like when I access it in my web browser. You can even define your own reusable tags. For example, in a plugin, if you make it parameterizable, it can be reused in a number of different views depending on what exactly you're doing. This is what the same thing looks like in Groovy. Again, a reference to the lib layout namespace. And then we create a layout element, and inside that we nest the main panel, and inside that we have our headline that we want to show. And that is all that's needed to create this view. For the next few slides, it is important to know a bit about the job type hierarchy. I put a little excerpt here. The important part is in the middle. If you have, for example, a freestyle project, one of its super types is AbstractProject, which inherits from job. This is all you need to know to understand the next few slides, because we're looking at inclusion by inheritance. And in this example, this belongs to the job type in Jenkins, which is the base class for our purposes. and it defines an index.jelly. So if you access the main page of anything that inherits from job, this is what you see. And as you can tell here, we have a number of these include tags defined by Stapler. And what they do is they include just, they include the content of that referenced view or page is the attribute in this case at that specific location. So we're including the side panel. Inside the main panel, we start off by including job property summaries.jelly, then main.jelly, and then the permalinks.jelly. And if you remember, or if you know what a job index page looks like, you may have seen those permalinks to, for example, the last successful build or the last stable build. And also still in job, it defines a main.jelly, but that doesn't do a whole lot. It's basically an empty view. And the idea is that subtypes of job define an actual main.jelly that has actually content. So you don't need to redefine the index view for each type or subclass in the hierarchy, similar to how you can override methods in Java. You can override views by just creating a view in a subtype. And it really doesn't matter what the details of this view are. It's just important that you see there's a whole lot more going on than in the default implementation I showed you before. Let's move on to actions. I have two examples of lists of actions on the UI here. On the left, you can see what various static analysis plugins can contribute to a job's main page. And toward the right, you see what actions contribute to the Manage Jenkins screen, where an administrator can configure various parts of the Jenkins UI. Action is an interface in Jenkins commonly used to add new objects to the model hierarchy. Action, the interface, defines methods that provide an icon, a label, both for use in the side panel mainly, and the URL name, and nothing else. Actionable is a supertype of many common types, such as job, run, computer, of course, Jenkins itself. And the idea is that actionable has methods that interact with actions, such as add action to add an action to the current actionable object, or get actions to return all of these previously added actions. And these actions are persisted with the model object. So if you save it and something has added an action to it, then that action will be part of the object's configuration. There are a number of different methods here, but these are the important ones for this presentation. And then one of the ways to add actions to an actionable in a way that will not be persisted is the transient action factory. This is an extension point. I won't explain what it is in detail. I think that was covered in the previous presentation on Jenkins development. But if you implement that, you will be able to provide actions to actionable objects. And these actions will be included in the results of the method called getAllActions by definition. And actionable, which is the supertype of all of these various types, has a method called getDynamic. And if you remember from the first part of my talk, getDynamic takes a part of the URL and maps it to an object. And in this case, it will check for an action with a URL name that is the current URL fragment. If it finds one, it returns that action and delegates the rest of the request processing to that action. Again, let's look at the job type hierarchy. In this case, the important part is that AbstractProject is an actionable and has all the methods defined on actionable, which I mentioned on the previous slide. This is a Jelly view defined for AbstractProject. The boilerplate at the top and bottom aren't really important. What we have here is first highlighted in red, a reusable UI component, which we will discuss in more detail later. And below that, there's a loop defined with the for each tag. And inside the loop, we're including a page called job main.jelly that belongs to that particular action. And the last attribute, optional equals true, just means if no such view exists, don't fail, just ignore it. And that is basically how something like a project's overview page can allow actions to contribute to that page. Another example, the previously mentioned reusable UI component, ProjectActionFloatingBox. It basically consists of a div that also includes a similar for each loop, iterating over all actions, which are the persisted and the transient actions. Again, including a page, in this case called floatingbox.jelly, that is defined on that particular action. So for any given action, we already have two ways to make it show up in the main area of a job. We have floatingbox.jelly, which is used for code coverage, test result graphs, stuff like that. And there's the job main.jelly that will be displayed below that. So to recap, I've talked about stapler request handling, both the common ways to handle a stapler request or continue processing it, as well as the less common ways, and how you can trace stapler requests to learn what's going on and really dive into the Jenkins internals. And in the second part, I've discussed views in Jelly and Groovy, including control flow, internationalization, and the most useful predefined variables and methods. In the last part, view composition with reusable UI components, inheritance, and how you can use actions to extend predefined UI. Time is running out, I'm afraid. So what did I not talk about? I did not talk about forms and structured form submission. The plan is that I will give another talk about those topics at a later date. libform is a tag library that defines a lot of reusable components for building a form. I did not talk about descriptors and data binding or form validation and things like very parameter annotations. But for all of these things, I've built this list of relevant links if you want to learn more. If you're basically learned everything I talked about today, then this is a good place to continue your exploration. Thank you. How are we on time?
We are fine on time. Thank you for the presentation, Daniel.
If I think it's useful, I can still do the demo.
Yeah, you can do demo. We don't have much questions. So if somebody has questions, please ask them in the chat or in the QA tab. And after Daniel's demo, we will discuss these questions.
Okay, let me just start. So the idea is I'm going to create a brand new Jenkins plugin that will demonstrate what I just talked about. Hold on. Need to open the project and then I will share the screen. Okay, you should be able to see my IDE. How's the font size?
It's fine.
Okay. So this is a brand new Jenkins plugin created from the Maven archetype. I'm just going to delete everything that's there to have basically the empty skeleton here. And first I will start by creating an action. Let's call it HelloAction. And it needs to implement action defined in Jenkins. As I said earlier, it requires 3 methods. The icon, let's call that notepad. The display name, let's call it hello. And the URL name, let's call that hello. And let's create an index view for it. I've prepared something because I don't want to write out all of the boilerplate. So here's Hello Jelly. Looks like that worked. However, nothing's actually adding the action anywhere, so I still need to add that. In this case, I'm implementing a transient action factory as mentioned before. And we need to tell Jenkins what class this works for. And it's the job class, and we actually need to create the actions here. In this case, let's create a new hello action for the project. And just because I didn't prepare the demo, get to compile again. This add extension annotation basically makes the factory known to Jenkins. Otherwise, it would be just a class that just isn't used from anywhere. That's cool. Good to know. What this does is get all actions in actionable, as I said earlier, includes transient actions. So job as an actionable will look for transient action factories or that match its type, hence this method. And any that match the type, it will call create_for, passing itself as the argument, and this will return a list. In this case, the only element in the list is the hello action I created earlier. All right, let's switch over to the web browser. There it is. Okay, so here we are. Jenkins, nothing going on. Let's create a job here. And as you can see, the job has been created and there's an action called hello on the left. And of course it doesn't work. Why doesn't it work? Because I created the resource file in the wrong folder. If you've been following what I've talked about, I've shown a slide where I show the project structure. And I showed how the views must always be in a folder that corresponds to the class. So in this case, the class is called HelloAction. And therefore, the index.jelly also needs to be in a folder called HelloAction. And that wasn't the case just now. I fixed it. I'm recompiling. Let's see what happens now. Aren't live demos fun? Let's go back to the web browser. And you can see here, it's printing the raw HTML. And the reason for that is I haven't defined the content type. If I do that, it will print not this raw HTML, but it will actually show in bold and large font this greeting. However, let's look at something else, and that is how to create a real layout. Let's reload this. Oh man, it's not my day, I think.
Daniel, you have about 5 minutes left for the demo.
Okay, that's not a problem. Just showing something else. And that is how to do a composite view here. In this case, what I'm going to do now is we've had this hello action that just prints hello. And now I want to create another action that extends from that and prints something else. And for that, I just give it a different URL name and a different display name. and create a new directory for its resources. So how is this going to work? I want to use stapler include to include the page called Hello Jelly. And in that page, I will repeat the greeting. For the Hello Groovy action, I will basically do the same thing, but define it in Groovy. That means an h1 element that says Hello Groovy. And to wire up this second action, I need to reference it in the ActionFactory. This is basically the same approach used by the job type to create the index page for the job. There's some default behavior, and in a subtype, you can override it. Just as if the views were some kind of Java method which you can override in subtypes to change behavior, you can also override the views in Jelly. So let's see whether this works. I've already opened the page here. There's the Hello view. It says Hello Jelly. And that part is defined in Jelly. And there's another page that says Hello Groovy. And that part is defined in Groovy. And now, last bit, let's look at, where is it? Oh, it's the wrong web browser. Great, I have no idea how to use Chrome. Let's see whether this works. We can see here in the HTTP response, can you read this? How's the font size?
Yes, the font is okay.
Okay, so here in the response, you can see various stapler-related headers. And let's look at the difference between the first one and the second one. Here, as you can see, this shows the Hello Actions index.jelly. And the other one shows, where is it? The Hello. Actions index Jelly. Something's wrong. I'm sorry, I don't think this demo works the way as I expected. My apologies.
Anyway, you are going to conduct the second part of this presentation at some point. So maybe
right. I think if time permits, I will create a sample project for what I actually intended to show, so we can provide this to all viewers on the meetup page, which will not be accompanied by my comments, but should give everyone a way to kind of see what I talked about in action in a very basic sample project size before diving into Jenkins itself. So thank you.
Okay, thank you, Daniel. So I do not see questions directly related to the presentation by Daniel. So I propose to discuss generic questions after Tom's talk presentation. So we will know how much time we have left. Tom, are you ready?
I am, yeah. Sorry, so can you see my screen there, yeah?
Yes, I've shared your screen, so it should be fine now.
Okie doke. All right, so as you've already heard, my name is Tom Fenley. So I've been working at CloudBees for the last couple of years. I actually came into CloudBees on the platform as a service side of the house, and I came from a background of more from the middleware side of things. So, so UI development and modern UI frameworks and stuff like that is not something I have an enormous background in, but I've over the last 2 years, I guess, since moving over to the Jenkins side of the house in CloudBees, I've been getting more and more familiar, and especially in the last year or so, we've been trying to do a lot more with more modern technologies, and that's what I'm going to talk about here today. Okay, so just to recap, and I'm not going to go into go into detail on any of the stuff that Daniel has done, but just to put a little bit of perspective or a kind of context around the stuff that we're doing, and I'm going to talk about here today. Just to kind of give a recap of up to this point, kind of the technologies we've been using in the past. So traditionally with Jenkins, as Daniel has described there, UI, and the UI has been typically been built on the server side. So we've used Jelly and Stapler and all the good stuff that Daniel talked about to build the actual UI and that gets delivered to the browser. Okay, and then by and large, though, JavaScript has played a kind of has taken a backseat really in the Jenkins UI, and there is JavaScript in it, but it's kind of stuff that was added on afterwards. It's not really, there's no real structures around how to build client-side UIs within JavaScript today. So this is the sort of stuff that we're talking about here. So the advantages of the current model, I guess, is the big advantages of were the easy conceptual model that Jelly and Stapler brings. Okay, so everything being on the server, it's kind of easier for people to get their head around all of the different concepts. So like the direct binding between Java and UI, the stuff that Daniel was talking about there, and the Stabler bindings and stuff like that. You don't need to build REST APIs or anything like that. There's no, the whole UI and the model around the UI is not split in across two kind of domains as such. Okay, so that's something that's made it a lot easier to build actual plugins and building an actual plugin model around a kind of a model that's located in one place simplifies a lot of things as well. Okay, so that model obviously has been easier for a big thing is the fact that that model has been a lot easier for non-UI people. So people that don't have a background in UI that start using Jenkins can easily get up and running and start building a plugin to kind of solve problems that they see and that aren't being solved at the moment. And that has led obviously to the huge number of, there's been a big part in the huge number of Jenkins plugins that are out there today. Okay, so that's the advantages of the current model. But the problems that we kind of encountered when we started trying to modernize the Jenkins UI were that we kind of came to the conclusion that model was while it was easy to create plugins, it was really difficult to create kind of modern and modern user interfaces that had a kind of a nice user experience that modern developers were used to. So people that are using GitHub and other development tools and development services online today kind of are familiar, are used to a certain type of user experience, and that was really hard to build with Jenkins using the model that was there. Okay, so yeah, so as I was saying, it we found it that was very difficult to build a kind of a reactive type of experiences into it, where you didn't have to reload pages and stuff like that. And then of course taking advantage of modern tools, because JavaScript was never really a first-class citizen in Jenkins, building client-side, modern client-side libraries and using modern client-side libraries was not something that was easy to do within Jenkins. And then of course, something we experienced in Cloudbees, I guess, was the fact that UI developers and getting people that understood Jelly and stuff like that wasn't something that was too easy to come by either. So they were the kind of the problems we had. So what we decided to do was kind of how are we going to build a more modern Jenkins user experience? But basically, what we decided to do was build a more modern tool chain and use more modern methodologies around UI development in Jenkins. So basically come up with new tool chains and methodologies that solve the kinds of problems that exist within the tool chain that has served Jenkins so well today, and kind of develop new models that would help us go forward. Okay, and then of course another thing we wanted to do was, it was obvious that we weren't going to be able to reinvent Jenkins, so we had to come up with a model that kind of fitted into the Jenkins world and what was in Jenkins today. So like, it's a Java world where you've got where Maven is a big part of the whole the tool chain around building Jenkins plugins and stuff like that. You've got servlets and stapler and adjuncts and stuff like that have advantages that we can, or things that we can take advantage of as well. So we wanted to build something that would fit into that world, and kind of that we could transition to more cleanly, if you like. Okay, so not a big bang to where we had to boil the ocean. So to do that, we had to come up with a kind of a newer kind of runtime model as such. Okay, so getting away from the purely server-side rendering, we have more UI code running in the browser. So we wanted to be able to use more modern JavaScript tools and libraries and methodologies. Of course, new languages like take advantage of the new ES6 JavaScript. Take advantage of CommonJS and the Node.js kind of a whole ecosystem there, and the huge number of tools and libraries that are out there for that. And of course, the more modular languages and stuff that are available mean more maintainable code, more testable code, and stuff like that. And basically, we'd be able to build a more reactive UI with no page loading. We take advantage of a greater advantage of REST and building REST APIs. And then actually rendering the UI on the client side as opposed to on the server side, getting rid of page reloads using technologies such as server sent events, so SSE as people might be familiar with, and then have less actual code on the server side. So traditionally, where we were using Jelly and Stapler on the server side, what we're moving towards is using the server side more to service REST APIs. So basically put REST APIs around the different data models within Jenkins, such as jobs, users and stuff like that, and allow the client to actually get at that data using Ajax. And then also using Jenkins itself and adjuncts, etc., to actually provide web assets to the UI, so to deliver to serve up JavaScript, etc. And then of course on the server side, that the server side would actually be the source of those SSE events. So while the client is listening instead of the client polling to get data from Jenkins, it would listen through an SSE channel, and Jenkins would push out events. So when jobs start or jobs finish and stuff like that, these events get pushed out to clients that have registered or subscribed for those events. Okay, so we'll look at these, of course, in more detail in a minute. And just to kind of to visualize that kind of model a little more, so you've got on the focus of the server then is more as a server and providing services to a UI that's running in the browser itself. So we're going to build the browser or build the UI with JavaScript modules that get bundled, and I've emphasized the word bundles there for a reason, and we'll see what that really means in a few minutes. And where that client-side UI and client-side code actually gets its data from well-defined REST APIs that are inside in Jenkins, and then the server is while it's doing work, starting jobs, jobs being created, jobs running and stuff like that, that events are being pushed out to the client, and the client is able to basically provide a more real-time view of what's actually going on in Jenkins, as opposed to what happens today in Jenkins, where you have client-side, little bits of client-side JavaScript polling on a timer and stuff like that. All that thing is gone out the window, and you have a nicer user experience and less kind of redundant calls to the back end to get information. Instead of that, the client just listens for registers interest in particular events, and when those events happen on the server pushes out an event to the client, and the client is able to react to that, whether that be make a REST API call or whatever to get more data or whatever. We're going to see this and the demo of all this in a minute, and it kind of shows how this can work today. Okay. So to do all that, we needed a new tool chain. So we wanted to use new languages, a new model for JavaScript and stuff, because we were going to be building more of the client UI was going to be in the browser. So we wanted to get away from the model that was there today, where we had like a Hudson behaviors.js with 20 different things, 20 different concerns kind of encode for different things inside in one file. So we wanted to properly modularize the code the same way as we modularize JavaScript code today. And the kind of obvious choice there for us was Node.js, CommonJS standard for JavaScript modules. Okay, so we wanted to write the code in that model. That made the code easier to test as well, and there's loads of frameworks around built around that. So the whole NPM Node ecosystem is huge, and we wanted to take advantage of that. Okay, so write the client-side code and test in these CommonJS modules. Now you can deliver CommonJS modules that can be used directly in the browser itself, but for example, using the likes of require.js. But what we wanted to do was, because there's no issues with that, basically as an application grows, you don't want to be loading individual JavaScript files over the web like continuously. So and as well as that, it involves a kind of an asynchronous model. So your code has to, like, if you look at, if anyone's familiar with require.js, it ends up where your code is more, the loading of those modules has to happen asynchronously because of the nature of loading things in the browser. Okay, so what we came up with, or what we started using, was one of these JavaScript bundlers, and there's a number of those out there. The one we're using in our toolchain at the moment is one called Browserify. Now, there are other ones out there that people may be familiar with, the likes of Webpack or Rollup.js, but they all do similar kind of thing. They take a graph of CommonJS modules, they analyze it and bundle it all together into one JavaScript file that can be loaded into the browser at runtime. So you load everything, that your bundles get loaded, and then within that bundle, you can maintain the kind of normal CommonJS synchronous require semantics that made Node.js and CommonJS modules popular and nice to use. Okay, so that's generation of the actual modules, and then the process. When we generated those modules, we want to be able to put them, basically bundle them into the actual HPI, into a plugin. So when you develop a plugin and you want to develop some of this JavaScript client-side code, you have a simple process for getting that CommonJS structure, which we'll have a look at in a few minutes now in the example, but getting it into your HPI build process and getting it incorporated into your plugin so it can be loaded at runtime. Okay, so the build process puts it in there, and we wrap it up. We wrap everything down. The Maven equivalent of for Java that we're using is a thing called Gulp.js. Okay, so there are other build libraries for JavaScript. People may be familiar with Grunt and Bower, or some of those that people use. We're using Gulp, and it's served us well. So it basically is a tool that allows you to write build tasks and to generate artifacts that get incorporated into your build. We'll have a look at that now again in a minute. And then, of course, we're working in a JavaScript or in a Java world and a HPI world with Jenkins. So we use a Maven plugin called frontend-maven-plugin to actually kind of wire all of this, hook all of this process into the Maven build lifecycle. So when you're building your Maven, your Jenkins plugin, and you want to incorporate these JavaScript components, it all kind of happens automatically for you as part of your build process, and we'll have a look at that as well in a minute. Okay, so the actual front-end Maven plugin, which is the kind of the hook into the current build processes in Jenkins, has been part of the profiles. We built profiles for using front-end Maven plugin into the plugin parent POM a good while ago. I forget the version, but it's a good few versions ago. And basically what it does is it's a set of profiles that look for, well, the one thing I didn't actually put in here is it downloads an appropriate version of Node and NPM for your platform. So it does this on the fly. You don't need to use this stuff. You don't have to actually install Node or NPM on your local system. Okay, this front-end plugin and the profiles that we've built into the parent POM actually take care of this for you. So say for example, if you're checking out a plugin that has this stuff in it, you don't need to install Node or NPM your local system. This thing takes care of everything. It gets the exact version of Node and NPM that your build requires, and builds your stuff for you. Okay, so it watches for a thing called a gulp file.js, which is the gulp script to actually build the JavaScript components and generate the artifacts out of that, and from that, yeah, it runs the tasks in that. And then we built some, so instead of having gulp files and gulp processes that were we found that we were repeating the same sort of process over and over, and we kind of codified the whole build process that we're using into an NPM package of our own called Jenkins JS Builder. Okay, and basically the end result is that in your plugin you end up with a nice, really concise gulp file.js, and in some cases, and in some cases in Blue Ocean, we've basically just got one line in it, which is to load the actual JS Builder. So one of the things we might try and do is look at a way of actually eliminating that gulp file.js, allow that you don't actually need to provide it at all, and if you don't provide it, we just run the actual JS Builder in the background for you. Okay, so anyway, it makes the build process, it kind of standardized our build process a lot. We kind of came up with conventions for where JavaScript code would be, where other UI assets such as less is a thing, is basically a CSS preprocessor. So it's a way of allowing you to modularize CSS. So rather than having your CSS in one big CSS file, like as is the case with Jenkins today, we basically define all the styles in less files, and we kind of modularize it. And a lot of frameworks use that today. There's a similar pre-processing thing called Sass. They're similar. There's advantages and disadvantages in both cases. We went with less anyway. Another thing the JS Builder does is it basically looks at your code and identifies that whether you've got ES6 code in there or not, and switches the language level depending on what it finds in there. Now you can manually control it as well, but it tries to make a guess at what you're using and set the language level appropriately. It runs linting on it, so we've got a standardized NPM package that defines the linting rules that we use, and we base that on kind of one of the more popular ones out there, which was defined by Airbnb. So basically, we're trying to have code that looks similar across the board. Then, of course, it does obvious things like running tests and generating reports that can go into your Maven build and stuff. And then the most important thing that it does is it takes these CommonJS, your code that's in CommonJS modules, and will actually provides an API to generate a JavaScript bundle. So a bundle is one JavaScript file that has a whole load of CommonJS modules kind of packed into it in a way that can be loaded in the browser in one go. Okay. And again, those generated artifacts, of course, as well. It's So it has understanding of how HPI plugins work and how adjuncts work and stuff like that, and it takes advantage of that. So when it's generating these bundles and processing the CSS and generating CSS from the less files, it puts them into a standardized place within the plugin, so that those resources can be loaded at runtime using the adjunct mechanism. And also automatically loading as well. So this is what we're talking about here is another package that we have, which is basically our loader for JavaScript. Not going to, this thing is fairly detailed. Well, it's simple in terms of what it does, but you could go into a lot of detail on this. But basically, what JS modules does, and it's a kind of a sister or brother, if you like, of JS Builder. So JS Builder builds bundles, JavaScript bundles that are JS modules friendly. And what I mean by that basically is that JS modules allows us to share modules across bundles. So with Jenkins, we're not going to create one big Uber JS bundle. We're going to have bundles for different plugins, but we want to be able to share different dependencies between those bundles. If you like, kind of like similar to a class loader, if you like, where you've got a bundle that has, in the case of Blue Ocean, a very important one is React. So one of the limitations or rules with using React is that there can only be one React in the system. So we make sure using JS modules, we can basically, in the Bootstrap, in the Blue Ocean Bootstrap module, we can export React from there, and then in all other bundles, we make sure that we import, and we've automated that as well. The React is not bundled in any other bundle. It's only loaded in one place, and all other bundles share that instance of React. So this is an important thing that JS modules provide. So it provides this ability to share between modules, and you can specify different version ranges that you can share. And if it doesn't, but it also handles the async loading of bundles. So where you've externalized, where you've split bundles up into multiple bundles, and so shareable libraries that are in bundles of their own, that JS modules will load those at runtime. So when it's loading your bundle and it sees that bundle needs, say, jQuery or something, it knows how to go and get jQuery for that bundle provided to it, and it does in an asynchronous manner that your code underneath doesn't really see. So your code still uses it in a synchronous way. But that's going into a bit too much detail. But there's two important modules there in terms of these bundles. This JS Builder, which builds the bundles, and this JS modules thing, which kind of is something that's will typically be in the background that you won't know about, but is the bit of magic that's kind of wiring all these bundles together at runtime. So importing and exporting different bundles based on information that it finds in your project. And I'll show you a bit about that now in a minute. And then the last thing, something that we just created the last day or two, was an archetype. And built this for Blue Ocean. We can build it for other stuff as well, but basically an archetype on the maven-hpi plugin. So maven-hpi plugin already has a create archetype to create a kind of a hello world plugin for you. And what we created for Blue Ocean was the same thing, but it creates a plugin that, instead of having that hello world sample based on Jelly and Stapler and stuff, it has a pure JavaScript plugin that uses all of these same technologies, but granted it is targeted more at Blue Ocean, but I think it's still very relevant. If you run this, if you use this archetype and look at how it works and are able to analyze it, you'll understand a lot of how JS Builder and how these newer tools are working. And it's also relevant. So that will be also relevant to Jenkins 2. So in Jenkins 2, where a lot of these building blocks are in place, for example, for the likes of the new installer. Okay, so I'll just going to give a demo now of using that Maven archetype, and from that then you'll see the different building blocks. Okay, sure. Sorry. Okay. the hell? Where it is? Sorry, guys. Anyway, I've got to run the actual archetype is the same as the other one. Now I've got to put in the version here because it's not published yet, but it's the same as the existing archetype. So the existing one is create. The new one is createboext, Blue Ocean extension. And at the moment, it runs and it asks you for the version of Blue Ocean. So this is the version at the moment that we're working on is maybe a new one, but that's new enough. The group ID, this is normal stuff. The artifact ID, so let's just call it today's date or today. The Tuesday plugin. Okay, so it's generated that stuff into that folder. CD. Okay, so if I open that now, hopefully this will start making more sense now. Tuesday. So I'm sure a lot of people, most Jenkins people have run the other archetype that I talked about, the one that's defined like the normal create one. And what it does is it creates a load of files in the resources here, and it creates a Java folder with it, the hello world builder, I think it is, so freestyle builder. So this archetype creates the actual stuff that's based on the newer technology that we're talking about. So the first thing that you need to look at, I guess, is, or the most important thing is the kind of top level thing, is this thing called a package.json. And this is for people that are not familiar with Node, this is Node's equivalent of pom.xml, if you like. So it's the place that you define the name of the package, give it a version, license, and then these scripts. But the most important part are these sections here relating to dependencies. Okay, so in here we've defined a dependency on JS Builder. This other module that I didn't mention earlier, but this is something we've kind of where we put in test-related utilities that we use, and we're defining the version. Now this is a special alias version that Node uses. Basically tells it to get the latest version, which it will do anyway if you're creating a new module or if you're installing from scratch. But so that's installs those guys, or dependency on those guys, and then they're dev dependencies, and then we've got these other special runtime dependencies. This thing called the design language. Now this is something that's in Blue Ocean, where I'll show you that in a minute. But basically, it's where we define kind of top level. It's like the bootstrap for the Twitter bootstrap for Jenkins, if you like. So where we define high level styles and buttons and stuff and what they look like, we've codified that into an NPM package that people can use, so that they can reuse the same styles, etc. JS extensions is the extension mechanism for Blue Ocean and the plugins that Blue Ocean are built on. Show you that now in a minute. We're going to build this thing. Basically is an extension here, and then JS modules, and then the SSE gateway. So what this sample plugin has basically in it is a simple extension for Blue Ocean. So here's the extensions file that for Blue Ocean looks for extensions. You define them in this file called Jenkins extension.yaml. Okay, and so we're going to the extension point that this extension is using. The name of it is this Usain, or the component associated with this extension is called Usain, which is basically, you'll see in a few minutes. It's and that points to the file there. So if you had it in a subfolder, for example, say you had a folder called components, if you had it in that folder there, that components there would change it. You'd have to specify the path there. So that's basically what that is. It's just basically specifying where the component is. So this is the extension point. That's the component that implements the extension point. and this is the name of the extension point that the component implements. Okay, so this component is implementing the Jenkins pipeline run result. So basically, it's contributing content to the run result page on Blue Ocean, and I'll show. We're going to run it here now in a minute. And then what also is in the plugin are these assets. So this is the less file we're talking about. So this is basically like your CSS file. It has different structures that you can that are not supported in. So less supports stuff that's not in CSS. So it allows you to modularize. You can define multiple less files there and import them. So you can break them up based on different things. So logos, different types of styles, and you can define things called mix-ins, which are like rules or functions that you can apply. So this one basically is a simple CSS file, and then there's some images that are used in here. So then the actual gulp file that we talked about earlier, as I said, most cases it's very simple, and in this case it's very simple. It's just requiring the JS builder. Okay, so the first thing when you're running this stuff is on the command line then would be run npm run. So there's different, if you look in the package that JSON, so you just have to click back, there's a section in it which is normal to a lot of packages at JSONs called scripts, which is basically where you can standardize on running, kind of shorthand for running different things. And it also means you don't have to install certain packages globally. So the likes of gulp, if you can run gulp on the command line directly here as well. So when you install gulp, you install it globally, and it'll install scripts that get run that are on your class path or on your system path that you can run. But if you don't want to do that, you can use the scripts as a handy way of doing that. So to see what scripts are available on any particular package at JSON, you can just run npm run, and it lists out the scripts that you have there. Okay, so let's run build, and you'll see what it outputs. So this is just running this is not running the Maven. Sorry, you need to install. I forgot that. So the first thing you need to do before you build anything in Node land, in any type of Node project, is you need to run a command called npm install. Okay, and what it does is it goes and gets all of these dependencies that are defined in your package.json. Now, if I run that now, it could take a few minutes. So what I have done in preparation for that is this is exactly the same project. Just ran it and call it something else, but I have already run the npm install. So after running npm install, what you'll see is a new folder will appear in the. So if you look here in the one we just created, there's no node_modules folder. But if you look here after running npm install, you'll see this folder here called node modules, which is basically it goes and gets all of the your packages, your Node packages, and puts them in here locally. Now it's kind of similar to Maven's local repo in your user home.m2 folder, but it's specific to this. So what it's done is it's gone and gotten all the packages in the package.json, but also all of its dependencies, and it does it kind of flattens it into creates a flat hierarchy out of it anyway. There's no need to go into that here. It's just standard Node stuff. Okay, so if I go over to that and run that one instead, so run build. Okay, so this is running. This is using Jenkins JS Builder now. It's basically running the gulp.js file, which creates a whole load of gulp tasks that are kind of specific to or targeted at the yeah. So the first thing it does, let's just go through it. Yeah, the first thing it does is it actually decides what it looks in your packages, your dependencies and stuff like that, and it also looks for like .jsx files. And it decides what language level to set it. So it's setting a TCMA version 6. Like if it doesn't find the Babel, so Babel is an NPM package for transpiling ES6 code to bog standard CommonJS type modules that can run, that can be then bundled and put into the browser. But without going into detail on that, it's basically analyzed the source tree and identified that you're using ES6 code and set the language level to that. And what that means then is it's going to install some of these Babel transpilers and apply them to your code. Okay, so you don't need to actually define. If you didn't use JS Builder, you'd have to define some of that stuff in your GULP file here. You'd have to define tasks to actually read the source code, pipe it through different transpilers, and to generate the ES6 or the transpile code. We don't have to do it with this. It's all done. JS Builder identifies this and does it for you. Then it just prints out some stuff, puts a link to JS Builder itself. The reason that's handy is that you can get and see the command line options that JS Builder provides. Then it looks and sees that it's a Maven project. Its name is BO demo. And then it starts doing some other stuff that we're not going to go into detail on here, but the main thing here are these tasks that are running down in this section here. So it starts running, it runs lint, it's using it doesn't find a lint file, but if you don't define one, it defaults to the Jenkins lint. So that basically, if in this model, then if people can we can standardize on one lint set of lint rules and use those. It prints out then what your source directories are. So the fact that it's a Maven project, it sees that it's going to look for source in source main.js, source main.less, and it's going to look for tests in source test.js. Now we don't have any tests in this particular one. And then it starts actually building the bundle. So it starts processing those JavaScript files and less files, and it automatically creates good tasks to actually generate those bundles and apply the appropriate tools to generate them. The end result of which are artifacts that get bundled into the into your HPI plugin. So basically, in the classes folder down here, it puts these based on the plugin's name and stuff. It drops the stuff into the class folder. So when you compile your plugin, they're going to end up there. Okay. So we're going to look at run now in a minute. Just trying to show what gets generated by this. So as you can see, the JavaScript file. So you've got a JavaScript file there. We've got this extensions file. Another thing to note, actually, JS Builder allows, we have a kind of plugin mechanism for JS Builder, and one of these dependencies here that we mentioned earlier is a thing called JS Extensions, which basically is the extension mechanism that Blue Ocean is using, and we'll look at that in a minute. It's kind of similar sort of idea as the JavaScript extensions that Daniel talked about, or the Java extensions that Daniel talked about earlier, but geared towards the client side. And that's what this using.jsx is basically. But this JS extensions actually defines kind of some additional plugins to JS Builder. And what that plugin does, one of the things it does is it looks for this extensions, JS extension.yaml file, and it processes it. And that's how we end up basically just having a GULP file with very little in it. The magic basically is in terms of defining the GULP tasks and stuff is being done within JS extensions plugin for JS Builder. Okay, so yeah, to look at that again, so it's processed the less file and generated a CSS file from it, and it has processed the actual the extensions and generated an extension bundle of it. So if you actually look in here, this is one of these browser file bundles that has all of the JavaScript code that your plugin needs. Now you can define, in your GULP file, you can define multiple bundles. Like you're not limited to one bundle per plugin or anything like that, if it makes sense. And in Blue Ocean, in the main top level plugin Blue Ocean, we define a couple of different bundles. But you don't, not all plugins will. Some plugins will just basically do this and here and define extensions that's basically it. So now let's run. So hopefully that gives an idea how the build process. So running the build process generates those artifacts based on JS Builder and its processing of the artifacts that it finds in your source tree. Okay. So if I start. So let's run the Maven build as well, just so as you can see. So if I run NPM clean install here. It runs the Maven build. And as I said earlier, if you just look at the POM, oh no, look at the POM in a sec, just let you see this. How am I for time, Daniel? Or Oleg?
So you have 15 minutes left.
We're nearly there anyway. So as it's running the Maven build there now, you can see that it's running this front-end plugin that we talked about. So front-end plugin is the Maven hook for running Node stuff. So it's basically gone and installed Node and NPM in the local folder. So it gets a specific version of Node and NPM, and I'll show you where it gets the version numbers for that in a minute. And installs those locally. So it'll download it, of course, if it doesn't need it, or if it doesn't have it on the local system, in the local Maven repository cache, it'll download. So you can see it looking here, got from cache. So it got Node for Darwin from cache and NPM from cache and installs. And all that magic is done inside the parent POM. So your plugin doesn't actually define any of this stuff. If you're using one of the newer parent POMs, you get this for free. And once you just add the gulp file and the package.json, if you run the build, it'll happen. Those profiles will get triggered automatically. So then, as you go down along here, you can see that it runs some of the gulp tasks. So it runs the bundle. It's bundling up. It's generating your bundles here, etc., etc. And it runs tests then as well. It runs lint. There are, in the parent POM as well, there are some, and this is defined in the JS Builder docs, I think. So if you go to follow this link here, you can see the command line options for turning on and off linting. So for skipping the tests and stuff like that, in the same way as you'd skip tests in Maven, you can skip I think if you run -d skip tests, it'll turn off the tests for the JavaScript stuff as well. Okay, so in this case there are no tests, so it has 0 specs, 0 failures, 0. So it hasn't run out there, but it's built the plugin, so we can just run it now. So if I just run it here in IntelliJ, hopefully it runs. So this is running. It's just running using the normal HPI plugin. So it's doing HPI run, HPI debug in the case I did here. So it's running, and if you look in the POM for this, that was produced by the archetype, it's the version 2.11 of the parent POM that it depends on. That's normal stuff. So here's some other. Here's some additional properties that get added. So we for Blue Ocean, we depend on a 2.x version of Jenkins. So it sets the version of Jenkins to be 2.7 to 3, the LTS version. And then here's the versions of Node that front end will actually install. So here's your defined version of Node and NPM that we're using. So these are versions we're using in Blue Ocean at the moment. There is a version 6 out, but we haven't started using that yet. And then the other interesting part down at the bottom here is the dependency on the main Blue Ocean aggregator plugin. So we depend on that, and that's pretty much all that's in. Oh yeah, so there's nothing in the plugin about front end or Node as such, other than the Node versions. That's the only thing that needs to be defined in the actual POM itself. Okay. So Jenkins is up and running there now. So before I run though, I want to actually just disable this plugin a little bit, because I want to show what normal so sorry, it's just in IntelliJ's index and stuff here. Come on. So one of the things that when you're in development mode, you don't want to be continually running bundle and stuff like that. And you want to be able to make changes to your JavaScript files and your styles and stuff on the fly and test them immediately in Jenkins, same way as you do with normal HPI plugin type stuff. Okay, so in order to do that, there's actually, if you run npm run again and look at the list, one of the tasks that's defined is this bundle watch. Okay, so bundle is the thing that actually generates the bundles and stuff. If you run npm run bundle watch, it runs the build process, but it stops it and watches for changes in the source tree. Okay, so that's the way you can kind of do iterative development as such. So it's an extra step that you're not, like, we could maybe build this into the HPI plugin in some way, I'm not sure. But at the moment, it is an extra step that you have to do that you don't have to do in Jenkins development today, but it's not a big deal. Run that command in the background, and then change something here. So comment out this. This is this file that we're in here now at the minute. Toolchain.jsx is a React component. So Blue Ocean, one of the main technologies we're using in Blue Ocean in terms of the rendering technology we're using, JavaScript render technology, is a thing called React, which people will be probably familiar with. So this is a React component defined in ES6 syntax. Okay, and it's like similar to the the way classes are defined in Java. So it extends from the React component, defines a constructor, and these are some lifecycle methods that are associated with it. So I just disabled the actual. I just made it render a simple. Here's the render function, and I just changed it to render a span at the moment. If you look back at the actual console here, you can see that the bundle has rebundled stuff a few times based on me changing code there. So if I load, so I'm looking for. Okay. And if I go here, log into Jenkins, I have a job here already defined. So this is Blue Ocean's console. So Blue Ocean at the minute, you can the top level console gives you a list of all of your jobs. And you go in here, you can see the activity on it, branches, so there's multi-branch and stuff like that. But that's not what I'm here to show you on this. So I want to just show what happens when I run a job. Or here's the activity page. So what the extension point that's defined here will actually put something in this area here. Okay, so above. So that this is the pipeline graph, what we call. Okay, so this particular job just prints a message and does a sleep. It doesn't do a whole pile. It's a simple workflow. It only has 2 stages in it. Okay, so but that stage graph is an implementation of the same extension point. So the extension point we define in this plugin should get rendered in the same area. So I've disabled it there now at the minute. So if I comment that out again, okay, reload that page. Okay, so it shows just a simple thing that dumps in. It just basically puts a div into the page, applies some style to it. The style being just an animated GIF. That's no big deal. But one of the things that I wanted to show here was the whole use of these SSE events and push events, and that's done through another NPM package that we've defined called for SSE. So basically, there's a plugin, a Jenkins bog standard plugin in Jenkins called the SSE gateway, and this is an API onto that gateway. And so basically, it allows you to register, subscribe to events in Jenkins. So there's different event channels, and this API here allows you to subscribe to that. So what we're doing with this in this example is in this lifecycle method. So this is a lifecycle method gets called on a React component at the very start. So when it's mounted, just before it kind of gets it is rendered, just before its render function gets called, this component will mount gets called. So what we're doing here is we're using the SSE API and we're subscribing to the job event channel. Okay, and then this is ES6 syntax. So this is basically a function here. This is the callback that gets called when there's a job event. So we're actually subscribing to all job events at the moment. Now there's documentation on the SSE gateway API on the plugin in GitHub, but you can also specify filters. So we could actually say I want to subscribe to the job channel, but I only want to listen to job events for a particular job. So you can filter by job name. So on the server side, then you won't even get this client won't even get pushed those events. So it'll get filtered out before it even get to the client. Okay, but what we're doing here in this example is we're subscribing to all job events on everything. So, and what we're interested in is the actual run end event. So when the run end happens, and it's for the same, basically the same pipeline, the same run of the same run of the pipeline associated with this component. So when you're on that page, you're on a run for a particular run for a particular job. So basically, make sure it's the same job, run of the same job that we're talking about. And what it does is it just sets the state of the component to finish. And what that's a React thing. So when you set the state on a React component, what happens is it'll re-render that component. And that's one of the things about React is it only renders the fragment that component is associated with. So you're not getting a full page reload. So with the combination of the SSE gateway and the events associated there, we're going to re-render just that part of the page, but only based on an event being pushed from the server. So when the job, so to see it in action, then you just run the job. Okay, so when we run the job, so these are all SSE based events as well. So we see the job happen. You see the animated GIF is different there. And then when it finishes, the GIF changes and the button. And this button that we're showing here, so this is the other last bit I was going to show you. So in the render here, we define a button and we give it a class name of button primary or button secondary. So where does that come from? So those button styles are basically coming from a thing called the Jenkins design language. Okay, so when you want to, and we're not doing anything with that button, it's just basically changes. So it goes from blue to white and the text changes on it in this example. But the Jenkins design language, and there's a site for it there. So if you go to the repo in Git, there's a link to the doc site there. And one of the things it has one of the things React has is a thing called React Storybook, which basically is a really useful thing that allows you to basically iteratively develop individual little React components, and it automatically loads and stuff. And what we're doing in the doc site here is we've used it we publish the storybook. So in JDL, we define all the components defined in the storybook, and then we add documentation to it. So this would be the place to go and get, like, this is the place to get the kind of the lower level button styles and stuff. Now there'll be higher level React components as well, not just buttons and things. So here's buttons, favorites. The pipeline graph is actually in here, but I'm not sure if it really belongs in here. So you can actually play with if you go to that site, you can play with these different components. Like you can hear, this one has a constructor on it. You can change you can kind of tweak the parameters associated with it. And then other thing, toast. The toast is a little thing that pops up in the corner. So when we kicked off the build there, you see a little toast popping up. That's a JDL component. So they're standardized. If you're building a plugin and you want to do this kind of thing, the JDL is the place to go to get that information. And we'll be adding more components and more documentation to that as time goes on. And I think that's pretty much all. So I had a link in the docs, or in the slides there as well. I have a link to more, just links to different things there. But if you I think nearly if you go to any of these, we have links off to the different ones, different things. So I think that's pretty much it.
Thank you, Tom. So I'm checking Jenkins IRC, but I don't see related questions again. I propose to start from questions from which we have in the queue, and if somebody wants to ask a specific question, just ask and we will address them. So regarding the questions, the first question is about Gradle integration. So if there is Gradle integration with Jenkins discussed in part 1 or part 2A test server, actually, I'm not sure what's it about. Daniel, Tom, maybe you know the answer.
Sorry, Oleg, where is the question? I couldn't hear you
if
there.
there is a Gradle integration with Jenkins discussed in part 1 or part 2.
Is regular?
Okay, I'll just try to answer.
I can't hear what you're saying. Sorry.
Yeah, no problem. Actually, you can build Jenkins plugins with Gradle. There is a project for it, and there are many examples in Jenkins plugins. There are some differences in publishing flows compared to common plugins, but the flow is operational, and if you want, you can use it for building plugins. But actually, there is not so many specific features available in Gradle, and we mostly use Maven for building our plugins. Okay. The second question is about test servers. Is a Jenkins server that's available for public, with just for remote testing configuration and simple job submits, which terminate jobs submission that last longer than 5 seconds or so? And the answer is that there is no such public server. Actually, it's not really required, because if you want, you can easily deploy your own Jenkins server using Docker or other images. It can be done via a single command. And actually, Jenkins itself doesn't produce much useful content. Jenkins requires installation of plugins, so you cannot just create a universal testing server for anything, for everything. So the recommendation is to just create your own test server. You can use Jenkins Docker project, which allows to specify plugins, which allows to make several additional configurations on startup and use it as a test server. I'll post the links to these projects to the meetup page. Okay, and another question is about plugin development. So Jay Hamilton has a simple goal, which is to create a drop-down that then dynamically gets content from a REST service. This works fine. However, he would like to have the user to select item in the list and have that item's value populate a text field.
Seems straightforward enough. This may need proper thread in the dev mailing list, but my suggestion would be to look into the JavaScript event that fires whenever the value of the drop-down list is changed.
Mm-hmm.
I don't think there's a ready-made component in Jenkins for that, so you'll need to get lower level than that.
Yeah, actually, there are plugins like dynamic parameter plugin or whatever. This plugin allow to select lists of available options via Groovy script, and in this Groovy script you can do whatever you want, including calling a REST service. But this approach has some limitations as well.
Yeah, I mean, that's a very specific use case, submitting the parameters. So my recommendation, Jay, would be to submit a thread to the dev list in which you explain this question in more detail.
Mm-hmm. Tom?
I was just going to say, I guess it depends on if you're working with, if it's classic Jenkins and Stapler and stuff like that. The answer that Daniel gave there is one answer, and then if you're using the newer stuff, then there's a different answer, which is like if you're rendering the UI on the client side, then it's quite easy to obviously to actually listen for events on the different component or different UI elements that you're rendering and stuff like that. Like even just using, like in the install, if you look at the new installer in Jenkins 2, there's loads of that kind of thing in there, like where you're interactively selecting different components in the list of plugins and stuff like that, and the list changes and what you see changes dynamically, and there's no it's all based on REST calls, like you're saying, and it's all like there's no page reloads or anything like that. It's all done within the browser itself. So it's kind of two different answers, I guess, to the same, depending on what you're doing, I suppose.
Mm-hmm. Yeah. I don't know about the design decision strategy architecture of Blue Ocean, and in particular the approach to the plugin strategy with JavaScript. What about a book?
Oleg, I think your audio was broken just now.
Okay, is it working now?
Yes.
Okay, so I'll just repeat the question. How can I learn more about the design decisions strategy architecture of Blue Ocean, and in particular the approach to the plugin strategy with JavaScript? Is it all open source? And another question, what about the book?
So it is all open source. The links I assume we'll be distributing the slides that we from today, and I've added links on the bottom of my slides, and I can add more links. And there is a link there to Blue Ocean. So there's a top level page, kind of project page on Jenkins.io, and then the actual repositories themselves have documentation within them. Like there's comprehensive documentation on the REST APIs. All of those other sites like JS Builder, JS modules, JS extensions, we try our best to add docs to those. We've added there's documentation to a certain level on all of them. Obviously, there could be better docs on everything. That's always the case, but we're improving it as we go along. So I think if you jump in there and fish around, you should be able to find definitely a lot of high-level slides and high-level information, and then lower-level information on the readmes and the repos and stuff like that. And then, of course, the dev list, you can post questions there. But yeah, I think, and it's something that will get better as time goes on. I don't know anything about a book, or if there's plans to write a book. I don't know if there's a.
Yeah. So regarding, sorry,
it's probably way too early to write a book, I guess, on it, but I'm sure maybe at some stage.
Yeah, so regarding Blue Ocean materials, the entry point is on Jenkins.io site. You can go to subprojects. There is a Blue Ocean page, and this Blue Ocean page includes overall overview on the implementation and also links to other materials. If you are interested about the development process, there is a blog in Jenkins, and Blue Ocean team regularly posts updates. I'm not sure about August update, but there was definitely an update from July. I just need to find it.
James Dumais is very good in this kind of way in terms of disseminating information on all of this kind of stuff. So, and I'm sure it's going to get better and better as time goes on. So,
yeah, and in the case you're going to Jenkins World, there is a meetup on September 13th, and this meetup is called the Jenkins Contributor Summit. And then this meetup, we will be discussing Blue Ocean architecture and other changes in particular. So if you are going there, join this event, and we will be able to discuss the stuff in details. Okay. So are there any other questions? The question from Alex Sumai: will you publish the Blue Ocean demo on GitHub or somewhere else?
Absolutely. Well, we can publish the demo, but it's going to get hopefully it'll be part of, I'm going to create a pull request on the maven-hpi-plugin, so it'll be an archetype on that at some stage. Maybe it still makes sense to publish it as a demo in its own right as well, but hopefully the easiest way will be for people to, if people want to just create a plugin, they'll just run the archetype and it generates it for them, and away to go.
Yeah, another approach would be to create a Docker-based demo like we do for Jenkins pipeline. And you just click one command and get instance with all configuration enabled and with several sample projects.
Yeah. We'll make it available in one and probably more forms, definitely, yeah.
Great, thank you. So, are there any other questions?
Where are you seeing the questions, Oleg? Sorry, I see some questions on the Q&A thing, but I don't see them anywhere else.
Yeah, I'm just checking RC and other channels, but there is no questions today. So I think that we are done with questions. As I said in the beginning of the presentation, we are going to publish recordings soon. If you have any question, please follow up on the meetup page. Just answer questions today in comments, and we will try to answer them as well. That's all for me. Thanks again to Tom and Daniel for making their presentations about the Jenkins Web UI. And we are going to continue these sessions. Maybe we will cover particular aspects of Web UI development and further meetups.
Thanks, Oleg.
Yeah. So thanks, everyone. See you at the next meetup at some point.